Hello. In this video, we're going to talk about generics in the world of Java. Okay. What are generics? Generics enable types, classes, and interfaces to be parameterized when defining classes, interfaces, and methods. Much like formal parameters are used in methods, in method declarations, type parameters let you reuse the same code with different inputs. The difference is the input to the formal parameters are values, while the input to parameter types are types. What's the point of all this? Well, say we were building our own custom arrays, like an array list. We would create a generic array that wasn't dependent on a particular type, because really we don't want our own custom array to just hold integers. We want them to hold integers or strings or floats or objects. So Java does provide some facility. What are the benefits as opposed to just using object? Stronger type checking. A Java compiler applies strong type checking in generic code. And it fixes compile time errors more easily because it identifies them. You also don't need casts. So for example, here we've got an array list, right? We can add a string, but when we bring it out, we have to cast it. With generics, we don't have to do any casting because our array list is of type string and can only take strings. So when we pull something out, we know we're getting a string. So let's consider a simple box class. We'll start with a non-generic version, right? It has two methods, set, which adds an object to the box, and get, which retrieves it. Okay, since it's so simple, I just plopped it out right here. We've got our private object, pretty obvious. And we have our set method, which takes an object and assigns it. Okay, we've got our get method, which returns it. Since they expect to return an object, you are free to pass in whatever you want other than primitive types without boxing them. However, there's no way to guarantee this is working correctly because we cannot verify compile types. There's no way to know that what's coming out is a string, and we can try assigning it to an integer, which could have bad results. So if we create a generic version, okay, so a generic class is defined with the following format. We have class name, and then in angle brackets, we say type 1, type 2, etc., where each type is a parameterized type, meaning we can reuse this elsewhere in the code as equivalent of a type. So here would be our generic box class. It takes a type of T, which is a very common naming convention, by the way. Everything else we want explicit names, but T is just typically used because for type. That's just tradition. Anyway, we declare a variable of type T. Don't care what it is because it's generic. Set assigns this .t to our inbound value, and get returns it. But we know it is whatever type it is, whatever type T is. So all occurrences of object here are replaced by T. A type variable can be any non-primitive type or a box type. This can be used to also create generic interfaces. By convention, type parameter names are single uppercase letters. This differs from variable naming conventions, but we want it this way to be able to tell the difference between a type variable and an ordinary class or interface name. The most common type parameter names are E for element, K for key, N for number, T for type, V for value. Typically, we will use T in this class. So how do we invoke and instantiate a generic type? To reference our generic box, which we declined, we must do a generic invocation. Box of type integer, and we'll call it integer box. Instead of passing an argument to the method, we pass a type. Like any other variable, this code does not actually create a new object, it simply declares it. We still have to create it. So now we'd still have to say box integer box equals new box integer. We have to tell it what type it is. Okay, there's this concept in Java called the diamond, and it's to help you do type inference. Other languages do this without the diamond, but still. You can replace the type arguments of a generic class with an empty set of type arguments if the compiler can determine or infer the typed arguments from the context. So box integer integer box equals new box. Well, we know we're declaring a box of integer, so we don't necessarily need that. I personally think if you're going to have the 2 diamonds, you might as well fill it in, but that's up to you. You can also have multiple type parameters. A pair, kv. Okay, so we got k, which has get key, and v, which has get value. And a class ordered pair, this is an interface by the way, which implements pair and has a private value key and a private value, and a constructor that takes one of each, and we create it, and then we have our methods that return generic type values. So the way we'd create it is pair string integer p1 new ordered pair string integer. It takes a string in the first position and an integer in the other. Similarly, we got 2 strings, and we got a string in the first and a string in the second. This instantiates k as a string and v as an integer in this case. When we instantiate it, we're going to get constructor will have string and integer as values. Because of automatic boxing, it's valid to pass a string into an int class. Since it can determine k and v from the declaration, we can use boxing here again. We can use, to create a generic interface, you use the same conventions as for creating a generic class. You can also substitute a type parameter with a parameterized type. For example, you could have an ordered pair of string and box of type integer. Okay? Or you could have, like, one very common thing is to have a list containing lists. Okay, now a raw type is the name of a generic class or interface without any type arguments. For example, class box t here, to create a parameterized version of box t, you supply an actual type argument. If the argument is omitted, you create a raw type. Therefore, box is the raw type of the generic type B. However, a non-generic class or interface type is not a raw type. That means basically you have to have both a generic and a non-generic if you have to have a generic if you want to create what's called a raw type. Raw types show up in legacy code because lots of API classes were not generic prior to JDK 5. When using raw types, you essentially get a pre-generic behavior. It deals with objects. So it's the equivalent of creating an object. You also get a warning if you use a raw type. Essentially, you should avoid using raw types except where you explicitly need them. You can also have generic methods, and they have their own type parameters, like doing a generic type, but the type parameter scope is limited to the method where it's declared. Static and non-static methods are allowed, as well as generic class constructors. So here would be an example. We have our public class util, which takes a k and a v type parameter, and we call it or a compare method, which takes k and v and then returns whether or not they're equal or not. We can also have a class pair kv, and which has its own methods. Okay, but util uses the pair class. So how do we invoke this method? Create a new pair, and then say util.integer string compare p1 to p2. The type has been explicitly provided in bold. Generally, this can be left out, and the compiler would infer the type. Sometimes you want to restrict the type that can be used as type arguments in a parameter's type. For example, a method that only operates on numbers might only want to accept instances of number or its subclasses. This is what bounded parameter types are for. To declare a bounded parameter type, list the type's parameters names followed by the extends keyword, followed by its upper bound, which is in this case number. So, class box t would be our basic one. We have our public inspect method, which takes u, which extends number. So if you give it something that's not of type number, it will puke on you. Here, this using a string would not work now. You can invoke methods defined in the bounds. So, for example, if we have n and it has an int value, because we know we're a subclass of number, we can call functions on or methods available on that number class, whereas with a pure generic we couldn't. You can have multiple bounds where it extends multiple bounds. Oops. In the types list. Classes must be specified first. Bounded type parameters are important for implementing generic algorithms. So, for example, if you wanted to take an array of numbers, if you bind the type, you can guarantee it's only numbers. And so we can have our extends comparable t, and that will allow us to compare comparable items. It's possible to assign an object of one type of an object to another type provided the classes are compatible. For example, an integer to an object, since object is a superclass. This is called an is a relationship. Integer is a kind of object, etc. The same is true with generics. You can perform a generic type invocation, passing number as its type argument, and any subsequent invocation of add will be allowed if the argument is compatible with the number. So here we can say box number. We can pass it an integer. That's okay. So if we have the following method, what type of argument does it take? By looking at signature, you can see it accepts a single argument whose type is box number. But what does that mean? Are you allowed to pass an integer or double? The answer is no, because box integer and box double are not subtypes of box number. They have to be subtypes. Okay. So number defines from integer, it's okay. Box number isn't a subset of box of integer. So you can pass it a subtype of number, but not a subtype of an instantiated version. So you can subtype a generic class or interface by extending or implementing it. The relationship between the type parameter of one class of interface and the type parameter of another are determined by the extends and implements keywords. Using the collections class as an example, array list of E implements list of E, and list of E extends collection of E. So array list string is a subtype of list of string, which is a subtype of collection of string. As long as you don't vary the arguments, you're good. So let's define our own list or interface, payload list, that's associated with an optional value of type P. And each element, its a declaration might look like interface payload E, P, extends list of E. And we have defined a set payload method. So the following parameterizations of payload list are subtypes of list of string. Payload list string string, string integer, etc. As long as that first value matches a string. Type inference is a Java compiler's ability to look at each method and corresponding declaration to determine the type argument that makes the invocation applicable. The inference algorithm determines the types of the arguments and, if available, the type that the result must assume. Finally, the inference algorithm tries to find the most specific type that would work with all the arguments. So, here, if we have our method T, notice here we don't have to explicitly state the types because it figures them out for us, which is kind of nice. Type methods introduce you to type inference, which enables you to invoke a generic method as you would an array method. You can also do the same with actual methods. The generic method addBox defines a one-type parameter named u. Generally, a Java compiler can infer the type parameters of a method call. In most cases, you don't have to specify it. So here, integer value 20, we don't have to specify it. If it needs to specify it, you'll get a compiler error. You can even replace when creating it, you can, just like before, replace the type arguments with an empty set of type brackets. Here we go once again. Also, constructors can be generic. Whoops. And have their own formal parameter lists. Consider the following examples. Here we go. Here's another one. It can have its own formal parameter list that is different from the class parameter list. So that's an overview of generics, and I hope you guys find that instructive.